Beautiful. So we're still looking at these circuits. We have already looked at the series circuits, and now we're looking at the parallel circuit. The parallel circuit, this is the second type. It's, when you think about it, think of the OR gate. With the parallel circuit, it has two or more paths for current to flow through. So with parallel circuit, it's actually easier because it has more than two paths, okay, where current can flow. So even if the other switch is closed, it's open, power can still go through and use another path. So for example, you can see here you have the battery, you have the lamp, of course, and this is how the parallel circuit looks like. They are in parallel, as you can see. We have the first switch there, the second switch. They are arranged in parallel just to allow those multiple paths. For example, if power has to pass through here and it goes through switch A, it finds that switch A is open, it can't go through. But then if switch B is closed, it will use this path and go through, and here it will light up this bulb. Same way, if at OR this B here switch was open and this switch here was closed, if it comes, it will still use this other path and still find the lamp and light it on. So it can have more than two, not limited to two, but not one also. So get this logic. It's what the OR gate or thumb laws use. So this circuit is an OR gate equivalent circuit. So starting with the first law, which is the identity, to say any variable that is ORed with a 0 is equal to that variable. So this is the circuit. Like I said, this variable here is just representing whatever value you give to A. So this circuit here is like switch A, sorry, this is a switch A. This switch here, we already have a 0 there, so meaning this switch is open regardless, it's already open. So if it's open, and let's say our A value is 1, if it's 1, it means power won't use this route. Since the switch is open, it will use this route and of course go there and light up the bulb. So meaning there, if A was 1, even though our results will be 1, because 1 means the bulb will go on. But then if A is 0, it will mean the switch will also be open as it is, and current will not go through, because all the two paths they both have open switches, so current can't go through. But then if one of them is closed, at least current can still pass through. So the equivalent circuit in a parallel with an open switch, the function value is determined by A alone. Okay, so whatever results here, they're only determined by A, because it's going to take the identity of A. Okay, then we have the variable that is ORed with a 1 is equal to 1, the 1 and 0 theorem. So the equivalent switching circuit in a parallel with a closed switch, the upper switch is permanently closed. That's why we have a 1 there. It's permanently closed, representing 1, which is on whatever value of A. Okay, this is already permanently closed, meaning that current will still flow through this path and light up the bulb, whether this switch was open or it was closed, whether it was 0 or it was 1. The results will always be 1. The bulb will still go on because it has an alternative path. If at all this path it cannot be used, current will still go through using this path here. Now the other law, which is the third law, also called idempotency. So for that reason, the equivalent switching circuit, A in parallel with A, they are both in parallel. So whatever A has, A also will have, and that's what the results will be. So if this switch is open and this switch is open, meaning they are both 0, 0, even the bulb won't go on because you've blocked both the path. Okay, so the final results depends on the value of A and A alone. If A is 0, the two switches are open, hence the circuit is off. And if A is 1, both switches will be closed here and here, and the switch will be on. That's why it's called endopotency, which is the same thing that reflects when you go back to product laws. So this is how you come up with the equivalent switching circuits. Once you know the difference between parallel circuits and series circuits, this should be easy for you. So as you can see, the properties of Boolean algebra, they're still being applied to come up with these circuits. Very important to note, because the AND get being a series circuit and the OR get being a parallel circuit. So make sure you know the difference and make sure you know how it works. Once you know the logic, nothing is going to be hard about this. Thank you for listening, and keep following my tutorials. Make sure you like the videos, subscribe to the channel so that you get updated every time I post another tutorial, and keep following until you get better at computer architecture. And of course, don't forget to ask questions where you haven't understood. Give your views and opinions. Make sure you like the channel, subscribe to it, remember to like it, leave your comments if you have to, and you can also contact me on my WhatsApp line if at all you would like further explanations. So thank you very much and enjoy learning.